Welcome to June 2023, Paper 2, Advanced Chemistry, Section A, Physical and General Chemistry. The A part of the question, number 1 reads, define a chemical bond. A chemical bond is a strong electrostatic force of attraction between atoms or ions in a substance. Last 2. State and explain the shapes of the following molecules. We have ammonia and we have boron trichloride. Okay, for ammonia, we know that, or we can see from the structure that the lone pair of electrons of nitrogen will pair the 3 bonded pairs more strongly, thereby forcing them to get closer to each other. Hence a trigonal pyramidal shape which we have here. And then the boron trichloride, the molecule has 3 bonded pairs of electrons only, which repel each other equally in the same plane, leading to a trigonal planar shape. Okay, the next part of the question reads, sodium 23 decays through beta emission and has a half-life of 12 days. What is meant by half-life? The half-life of a radioactive substance is the time taken for its amount of activity to reduce to half its original value. And in the next part, you are asked to write a balanced nuclear equation for the beta emission of sodium 23. Okay, so sodium 23, we know that for sodium has atomic number 23. 11 and mass number 23. So when it undergoes beta emission, we produce a beta nuclide whereby the mass number will be 1 greater than that of the original or the parent nuclide. So this is 11. The atomic number of the beta nuclide will increase by 1, so we have 12. While the mass number of the moon is the same, so we have 23 plus the beta particle which means 0 minus 1. And then we have that. So that is the nuclear equation. We have the next part. Calculate the mass that remains when 1.25 gram of the sample undergoes decay for 60 days. So we can solve that mathematically by saying the amount at the time t nt is equal to the amount at the origin or the start m0 in bracket half raised to the power n, where this n is equal to the number of half-lives which is given by t on t half. So we have nt implies that nt is equal to 1.25 into half is 0.5 raised to the power t is 60 and t half is 12. So we compute this, we have 0.0391. Alternatively, we could proceed by saying that we have 1.25, which is the original amount, decaying to produce 0.625, which is the half of this. That's 1 half-life. Since we have 5 half-lives, we'll do this 5 times, producing 0.3125, which is the half of this. That's another half-life we have undergone. We're going to produce 0.078125, which is the half of this, and lastly going to produce 0.0391, which is actually the fifth or half-life. So the number of half-lives is 5, as you can see from here, 60 divided by 12. So this is the alternative method we can solve this. Or you could proceed by applying the formula nt. Our English formula nt is equal to m0 e raised to the power minus lambda t. In this way, we will actually look at lambda, where lambda is going to be ln 2 over t half. So lambda is equal to ln 2 over t half. When we do that, we have 0.693 divided by t half, which is 12. That's half-life is equal to 0.05775. Now we can proceed to look for our nt by putting n1, which is 1.25 times e raised to the power minus 0.05775 all over. Then this part times t, which is the time there we are given is 60 days. So we compute this, we still have 0.0391. Either of the three methods can solve this problem. Okay, we proceed to the next part of the question, which is the C part. The C part reads: in an experiment to determine the molar mass of a volatile liquid, 1.715 gram of a liquid was evaporated at 40 degrees Celsius and 2 atmosphere, releasing 488 cm of vapor. Roman 1. State the experimental method used in the determination of the molar mass of the liquid. Okay, the correct answer there is the gas syringe method, or you may say the Dumas method or Victoria's method, but the most accurate answer or the common answer is the gas syringe method. But alternatively, you could also use the Dumas method or the Victoria's method. Okay, the next part we are asked to calculate the molar mass of the liquid. So we know that the ideal gas equation says PV is equal to nRT, but this N is not area, is giving mass over molar mass, which is the number of moles. So we have here PV will be equal to the given mass small m over the molar mass RT. From here, if we transpose, we see that molar mass will be equal to nRT divided by PV, and this implies the molar mass will be equal to the mass that is given in the question is 2 times the 1.715 times the molar gas constant is 0.082 times the temperature that was given in the question was 40 cm cube. We convert that into Kelvin, we have 313 divided by, we have the next the pressure 2 atmosphere times we have the volume given in the equation as 488 cm cube. When you convert that to cm cube, we have 0.488. When we compute that, we have 45.1 grams per mole. Take note, when using this formula to calculate the molar mass of a volatile liquid or molar mass of our unit of R, where R is 0.082 atmosphere cm cube per mole per Kelvin, our temperature must be in Kelvin, our pressure must be in atmosphere, and our volume must be in cm cube. So that is why we are converting. We have 45.1. Alternatively, we could solve this by applying the combined gas equation, and then we correct by actually determining converting the data we are given into values at STP, and then from there we correlate, we still have the same answer. This is the easier method we could use. So we have the G part of the question, which reads: potassium chlorate 5 decomposes in the presence of manganese 4 oxide catalyst to release oxygen. Write out a balanced equation for the decomposition of potassium chlorate. Okay, so potassium chlorate is solid. When heated, will produce potassium chloride, which is a solid plus oxygen. So we balance the equation by putting 2 here in front of potassium chloride, 2 in front of potassium chloride, and then 3. The next part of the question says we should calculate the volume of oxygen produced at SCP for the decomposition of 0.73 gram of potassium chloride. Okay, there are 2 or more methods we could be able to use here, but the simplest method is by simply going to the formula and we say that from here the molar mass of potassium chloride when calculated will give us 122.5, and then we can say that 2 times, that's the number of moles, 2 times 122.5 grams of potassium chlorate 5 produces 3 times, I say 3 because we have 3 moles here, so this is a mass volume relationship from equations. So 3 times 22,400 cm cube of oxygen. In other words, the molar mass of potassium chlorate produces the molar volume of oxygen. So 2 times the molar mass of potassium chlorate will produce 3 times the molar volume of oxygen. Therefore, 0.73 grams of potassium chlorate will produce 3 times 22,400 times 0.73 divided by 2 times 122.5, which is equal to 200.23 cm cube. Or we could proceed by working in terms of moles and then correlating to get the volume. That's the alternative method we could use, but this is quite straightforward. Okay, we proceed to E. The E part of the question says an ideal solution contains 0.85 moles of methanol and 0.42 moles of ethanol. The vapor pressure of the pure methanol and pure ethanol at 20 degrees Celsius are 98 millimeters of mercury and 43.6 millimeters of mercury respectively. Calculate Roman 1 the mole fraction of each component in the mixture, and then Roman 2 the partial pressure of each component in the mixture. So the total number of moles MT is equal to the number of moles of methanol plus the number of moles of ethanol, which is equal to 0.85 plus 0.42, which is equal to 1.27 moles. Now, the mole fraction of methanol is equal to the number of moles of methanol divided by the total number of moles, which is equal to 0.85 divided by 1.27, which is equal to 0.6693 moles. The mole fraction of ethanol is equal to the number of moles of ethanol divided by total number of moles, which is equal to 0.42 divided by 1.27, which is equal to 0.3307 moles. That's the mole fraction. Okay, the next part of the question asks us to calculate the partial pressure of each component. So the partial pressure of methanol will be equal to the mole fraction of methanol times the vapor pressure of pure methanol, which is equal to 0.6693, which we got above, times the vapor pressure, which is 98. That will be the partial vapor pressure of methanol in mixture, which is 65.59 millimeters of mercury. We proceed to get the mole fraction or the partial vapor pressure of ethanol, which is equal to the mole fraction of ethanol times the vapor pressure of pure ethanol, which is equal to 0.3307 times 43.6, which is equal to 14.42 millimeters of mercury. We proceed to get the total vapor pressure of the system, which is the next part of the question. The next part of the question says we should calculate the total pressure of the mixture. So the total pressure of the mixture is equal to the partial vapor pressure of methanol plus the partial vapor pressure of ethanol, which is equal to 65.59 plus 14.42, which is equal to 80.01 millimeters of mercury. Question 2. Question 2 says we should name two close packed structures giving an example of each. We should name two close packed structures giving an example of each. Okay, the two close packed structures we have hexagonal close packed, and under that example we have zinc, magnesium, cadmium, beryllium, scandium, titanium, platinum, and graphite. Those are examples that we have for hexagonal close packed structures. Then we have the next one being face center cubic or cubic close packing. Example, we have calcium, silver, we have gold, we have aluminum, we have lead, we have platinum, we have copper, strontium, cobalt, nickel, platinum, rhodium. Then for compounds, we have sodium chloride, potassium chloride, calcium oxide, silver chloride, and zinc sulfide. Those are examples of substances that exhibit the field center cubic, or what we call the cubic close packing structure. We proceed to the B part, which is on energetics, where we are given some useful data and we are asked to calculate the enthalpy of formation of carbon disulfide. So if you look at the data we have carbon reacting with 2 moles of sulfur producing 1 mole of carbon disulfide. So we could solve this by looking at the formula delta H delta formation, enthalpy of formation of carbon disulfide is equal to the sum of the enthalpies of combustion of the elements minus the sum of the enthalpy of combustion of the compound. So from the data we have delta H. This implies delta H delta formation of carbon disulfide is equal to the enthalpy of combustion of carbon plus 2 times the enthalpy of combustion of sulfur minus the enthalpy of combustion of carbon disulfide, which is equal to minus 393.5 plus 2 times minus 296.9, then all of this minus 107.2, which is equal to minus 875.5 kilojoules per mole. From how did I get the enthalpy of combustion of sulfur? From the equation, we see that sulfur burns complete to produce sulfur dioxide. So this is the enthalpy of combustion of sulfur. Carbon burning complete to produce carbon dioxide. So this is the enthalpy of combustion of carbon dioxide. And of course, from here we see that carbon disulfide has completely burnt to produce carbon dioxide plus sulfur dioxide. Alternatively, we could do this by simply reversing some arrows. The arrows in the first two in order, so that since we have carbon sulfur dioxide and carbon dioxide in equations 1 and equation 2, and in this other equation on the right hand side, we reverse this equation 1 and equation 2 so that the carbon dioxide and sulfur dioxide will rather be on the reactant side, so that we can cancel out this one, while we will now be able to correlate the values and we will come to the same answer. That's the alternative method we can proceed to this. Equation 2c. Peroxodisulfide ions react with iodide ions according to the equation peroxodisulfide plus 2 iodine producing iodine plus 2 sulfate. And then we have the experiment initial concentrations of peroxodisulfide and iodide and then initial rates given. So we are asked to what is the order of the reaction with respect to peroxodisulfide ions and with respect to iodine ions. So for A, which is with respect to peroxodisulfide ions, because
at classgate.com we have free solutions to all Cameroon GCE past questions. That is both for advanced level and ordinary level. When you go to Classgate, the first thing you have to do is log in. Log in right here. And you'll see you are able to log in with your Gmail account. So if you don't have a Gmail account, it's preferable you create one right now so that you can enjoy all free solutions, all free courses for the success in the GCE. Now I'm going to handle how to enroll for free courses and paid courses in this tutorial. So let's enjoy. Upon successful login, you'll be prompted, are you a teacher or are you a student? So you can see Classgate is for both teachers and students, but since it's a student-based tutorial, you're going to select I am a student. You'll be directed to your profile page, but this is not what is important. What we have to do is we have to study. So you search for the course you want to study. And in this example, we're studying biology. So I'm searching for biology, and you can see all biology courses on Classgate. That's both paid and free. Classgate is offering solutions to Advanced Level Biology 2019 Paper 1 for just 100 francs. And Classgate is also offering solutions for Human Biology 2021 Paper 1 for just 100 francs. And under free courses, you can see the Cameroon free courses. You can see the Cameroon GCE Advanced Level Biology on the year 2020 Paper 1 all for free, and Human Biology 2021 Paper 2 solutions for free. What you want to do is you have to enroll to your free courses right now. Okay, so you click the enroll now button. You click the enroll now button, you'll be directed to your dashboard, and you can start the course anytime you want. So I'm starting the course, and this is our classroom. You just have to be patient, your course will get loaded. Produce pyruvate. Well, the answer is definitely D. If you want a full screen mode, just click here and you are enabled to full screen mode. You can select the quality you want. If you want lesser quality which require more data, you select 180 pixels. Okay, if you want to speed up the course, just select 2 times. Okay, and everything goes faster. Okay, and you can escape from the full screen mode. Classgate also has a place for you to ask questions, okay, and the teacher of this course is going to respond immediately. And you can also ask questions. The questions are public, everybody can see it. Now let's go on how to do a paid course. We're searching biology again, and we're searching. To pay for services on Classgate, this is what you want to do. You click the add to cart button, okay, and you select this blue notification right here, and now you're redirected to the checkout. You can see this is the card icon right here. You can also click it to be redirected to the checkout. And here, proceed to checkout. What we are buying is Cameroon GC A-Level Biology MCQ 2019. You'll be prompted to enter your phone number. When you enter the correct phone number, you can save the phone number on Classgate, or you can choose not to save, depends on you. Click a complete payment button, and then you'll be prompted to you see a flash message will appear on your phone. You'll be prompted to enter your mobile money pin. If you don't see the flash message, just dial *126# and the flash message will appear. If you're on Orange, dial *150*50#, okay, and the prompt also appear. Upon successful payment, you can see payment has been successful notification. Click here for your invoice. Okay, you can click here, you see your invoice, you can download your receipt. But what we're doing is we're enrolling for a course. So let me go back to business. Now search for the biology course. I want you to take note of this difference. When you pay for a course, the icon changes from add to cart to start course. You see it has changed from add to cart to start course. So you just start the course immediately. Play, just wait for the course to load. The course will be loaded. Click the play now button, and there you have your course. What are soluble end products of carbohydrate and protein? Digestion through the intestinal mucosa into the blood capillary of the villi is by A. Diffusional osmosis, B. Diffusional active transport, C. Endocytosis and exocytosis, D. Endocytosis and pinocytosis. The correct answer here is the transport of soluble end products of carbohydrate and protein. Digestion through the intestinal mucosa into the blood capillary of the villi is by A. Diffusional osmosis, B. Diffusional active transport, C. Endocytosis and exocytosis, D. Endocytosis and pinocytosis. The correct answer here is